What's going on, guys? My name is Amos and I'm back again with another video. So in today's video we want to continue with our series. We want to continue with building the most awesome Autonlib library for automata theory. So let's first of all recap what we've done so far. So we defined in the very first video we defined, I think in the second video we defined the structure of the automaton and how we're going to represent the automaton in memory and all that good stuff, and all that information is in the auton.h file. So this is what we have. And yeah, we wrote memory safe wrappers to be able to allocate memory. We have auton colloc, we have auton malloc, we have auton realloc, and yeah, we have all sorts of good things. And then of course we are compiling with CMake. CMake is going to automate the generation of make files. If you look at our build folder, you can see that we have this make file here that was generated by CMake from this CMake list.txt file. Yeah, and we also generated this this executable that we have here that we can run. And I think in the previous video we sort of like tested a few things and we printed out a few things on the screen using auton print. In this video we want to change things a little bit. We want to first of all look at how we can add transitions, because right now there is no way to add transitions. So to fully define an automaton in memory, what we are supposed to have is a way to sort of like add transitions, add sort of like complete what we have, because we already have the alphabet, we already can define states, and then we now want to see how we can add transitions and see how everything is going to look. And probably near the very end of this video we're going to see how we can generate a dot file that we can feed to something, to some engine, to maybe to Graphics or anything that can generate the graph of that particular thing. So we want to be able to look at how we can generate dot files. So we'll write a function for that. So we'll start simple, and as we progress, some of these things are going to change. Things are going to become complex, and things are going to we're going to like follow the best practices more and all that. And probably later on we're going to create another header file, autonlib.h, for example, where we're going to like define all the library related variables and things like that, to shorten things, to shorten some data types and things like that, to make things cool and simple for us, and to like follow all those best practices, right? So that is what we want to do. And for now we'll start simple. Maybe the function that we're going to implement for generating dot files is going to be simple, and yeah, but we don't want to worry about that for now. I just want to make sure that everyone understands, to make sure that we are all on the same page, right? So that is what we want to do. So let's first of all so we'll write the function for adding states in this auton.h file. In this auton.c file, this is where we'll write the implementation. Now let's look at the signature. Now before we even do anything, look, there's here, for example, here we are passing a pointer to automaton. So what if they give us something that is no, for example, something that is not yet initialized, okay? For example, if automaton points to no, it means we'll get a segmentation fault here, because we're trying to loop through things, or we're trying to access memory that does not exist, memory that we've not allocated, because what they've provided points to no. So we sort of like need to write maybe a simple macro that is going to asset these arguments, and make sure that the user, or whoever is going to be calling this function, or whoever is going to be using this function, provides a value that is not no. So we'll probably write a macro before we do anything else, and I'm going to write it here. Well, of course, if need arises, we'll like move it to a more centralized location if we really need to use it in other places and things like that. And well, who knows? So things might change, but for now this is where I want to like use it, and to sort of like not like move around a lot and write things here and there, just keep things simple and all that. I'm just going to write the macro here. So how we're going to write this macro is, we're going to start with define, like so, right? So I'm just going to call this asset. So I'm just going to say asset not no, okay? Even the name later on can change, and for now we're just going to worry about a single argument. Maybe if we have functions that take multiple arguments, we would want to like maybe receive as many arguments as as the person who is calling the function provides. But well, we just worry about a single argument, and we'll like repeat calls to this asset not or macro. Yeah, so let's just look at that. So we're taking an argument. For example, it can be automaton, so anything, right? It can be automaton. For now, we're just using it for automaton, right? So we're taking an argument, and how we write a macro, I want to write this on multiple lines. So to be able to write this on multiple lines, on the first line, I just want to have the name of the macro, and then I'll put the backslash like so, and maybe do a tab like so, and then I'm going to use a do while loop to help me write this particular macro. And I also want this to spawn, to be written on multiple lines. So I'll do this. And here the condition is, well, we want this to run at most once, right? We want this to run at most once, right? That's what we want to do. Okay, makes a lot of sense. So we have that. Now, if the argument that we pass in, if the argument that we have, now, in case they pass in a complex structure, we want to make sure that we read the correct value, right? In case they, pass in a complex argument, or they write it in a very complicated way, we just want to make sure that we do the correct thing. So instead of like writing arg is equal to no, I'm just going to put the arg in parentheses. That is going to take care of, a lot of like, problems later on if they sort of like provide as an argument a very complicated or a complex macro, and we sort of like have to receive it the correct way. Okay, great job. Now that makes a lot of sense. Now if it is equal to no, then we need to, and here I have to do something like this to make it to write it on multiple lines. I have to write it like this. And even I think here I have to do the same thing, like so. Remember, we are writing it on multiple lines. So if the argument is equal to no, well, we want to do something. We want to call fprintf. We want to print to the standard error, like so, to the standard error. And hopefully we did not do anything wrong here. And it could be useful to print the file. And maybe let's write a simple message here. Maybe we'll say asset like so. We'll do asset like so. We'll do asset. So that makes a lot of sense. So if we do like something like asset, asset, and then maybe we can provide a message here. We can just say %s like so is no. So we want to, the string representation of the argument is what we're going to provide here. So for example, we'll say whatever they call it, maybe automaton is no, or auth is no. It cannot be no, something like that. So a message like that. That is what we want to see. Then it could be useful to like tell them in what file this maybe it could be useful to know the file where this problem, where this happened, and on what particular line. So right, so we'll have to say %s %d for that. And then here I have to like provide the new line like so. Okay, and that makes a lot of sense, right? That makes a lot of sense. So we have that, and then we have to pass in the string representation. So the string representation of whatever argument they pass in, right? And then we need to throw in that file. Let me just do this. We need to throw in that file, and then we also need to know the line, right? The line. So the file, what we've written here expands to the name of the file, and then this expands to the line. Well, it tells us what line the error happened. And if I do something like this, this allows me to write the macro on multiple lines, right? Great stuff. So we have a lot of errors, I think, here. what does it say? No, these are not these are not errors. I thought for once that these were errors, right? So I got worried. This worked in the previous video. Why do we have these errors now, right? So this is what we want to do, right? So let's go through. So we've defined the macro. We are calling it asset no. We pass in our argument. We make sure that we correctly wrap it in parentheses in case we have a complex argument, in case we receive a complex argument, and we want to handle that correctly. We don't want our macro to fail because it would really mean, it wouldn't be a good thing, right? So if the argument is equal to no, then we want to print the standard error, this message here. So we'll say asset, then percentage %s. This receives the string representation of whatever the argument is that we pass in, and then file, this tells us the file where this particular error happened, and then this tells us the line on which the line on which this particular error happened, right? And everything here looks good. So we should be able to do something like so let's now so that is what we have. Now let's now look at how we can like add transitions. How are we going to add transitions? How are we going to add transitions? Well, the very first thing that we need is, a function to be able to do that. The function that is going to do that for us. So remember that all public functions are going to be prefixed with the name Auton. So we'll say Auton, and then we'll say add transition. For example, we'll say Auton add transition, like so. Now, what do we need to receive? So to be able to define a transition, what do we really need? To define a transition, what do we really need? So we need an origin, then we need a destination, and then we need a symbol, the symbol that we are reading. So that is what we basically need to be able to do what? To be able to define a transition. We need an origin, we need a destination, and then we need to read some input, some symbol of the alphabet, right? That is what we need to define a transition. So Auton add transition, the very first thing that we're going to receive here is it's a pointer to state t, like so. So we're going to call this origin, like so, and then we'll need another pointer. So we'll say state t, and then this has to be the destination. So I'm just going to like name it the whole thing, destination, like so. And then we finally need a symbol, right? We finally need a symbol that we're going to read. We need a symbol, right? We need a symbol. Now, how? So here maybe what we can do is that we'll say we need a const, maybe const, I think const char, like so, right? I think that looks good because we'll read the symbol as a string. So this is what we receive. Okay, this is what we receive. That looks good. And before we even write the body of this particular function, I want to grab this function and do we need to return anything? No, we do not need to return anything. Maybe a pointer to the transition that we've just added in case we or for now we're not going to return anything. We'll just leave it the way it is. Now, before we write the body of this particular function, I want to go into automaton.h and prototype this particular function here. Now, I'll just put it after after init automaton, like so. Doesn't really matter where you put it, as long as it's in the file. And we need to like be able to see this this function because we test this function, right? So what is the first thing that we want to do? Well, the first thing that we want to do is to make sure that and in our macro, probably what we have to do here, if it's no, we also have to like exit, right? It's also important to exit here because yeah, we don't want to just print out, we print something to the screen and that that's no, we cannot just do that. So we have to like exit, and I think we have to do exit failure. Yeah, exit failure, semicolon, and then forward slash. Do not forget the forward slash, otherwise things are going to get things are going to fail, right? Great stuff. So let's asset. So I think here we'll asset no, like so, and then we'll pass in the origin, like so. Now, like I said, we can write a macro that processes maybe at the same time all the arguments that we pass in, but for now we just like have multiple, we'll just like make multiple calls to this macro that we have here, and then we have to provide the destination here. So if these are no, then we cannot define the state, right? We cannot define the state. So I'll like write it 3 times, like so. We could have done it in one go. Yes, that's possible, but well, we just want to keep it simple. We just want to understand like the importance of like validating our argument and making sure that they are not, I think we should also do the same thing for symbol, like so. And the rest of, what follows now is like the logic, right? Is the logic of, how we can add the transition. Well, the very first thing we need to do is to allocate memory to store the transition. Remember that a transition, we define the structure to store the transition. And let me just remind you, in case you've like forgotten, this is what we are supposed to make reference to be able to add or define a transition. So these are the properties that we need, right? These are the properties that we need. Great stuff. So we need to allocate memory to be able to store this transition that we have here. So if I go back to auton.c, the very first thing that I want to do is at node. Okay, I need a pointer to at node, and then I'm just going to call this one new transition because it's a new transition we are defining here. Just want to call this new transition, and then this is going to be equal to, well, we already have our memory safe wrappers. Now we want to cast into this at node, like so, and then we're going to call auton malloc. Yeah, we want to call auton malloc, which is this function that we have here. Now what do we need to pass in here? We need to pass in the size. So we want the size of a single transition. Okay, the size of a single transition. Great stuff. So this is what we're going to have. Okay, remember that we're already doing the checks, and if it fails and all that, we're already doing the checks in the auton malloc function, in this memory wrappers. We're already doing the checks, so we're not supposed to like verify if like everything is okay at this particular point, right? Because we're already doing it in the auton malloc function. We're already checking whether the memory has been correctly allocated, or maybe we're still pointing to no, for example, if malloc fails. So we're already doing that. So we now have a pointer to this transition. Now let's now think about how we're supposed to let's think about how we're going to initialize all of this. So let's look at the properties that we need to be able to define a transition. So we'll go back to our auton.h and look at the structure that represents a transition, a single transition in memory. So we'll have a symbol, we have a state, a from, and a to, and then next is a pointer to the next transition of the same state, right? That is what we're supposed to do. Okay, now the very first thing that we're going to do here, we're going to set the origin. So we're going to say new transition, and then new transition, and then from, we're going to say this is going to be equal to the origin, and then we're going to say new transition to is going to be the destination, like so. Great job. And we want to like copy the symbol. We want to copy the symbol. Now let me just move and put it, I have something here. Probably have to do string copy here, string copy, like so, then terminate that. Now what we want to do is we want to say want to copy into new transition input symbol, whatever the symbol whatever symbol that we pass in here. So this should like take care of the symbol that we are reading, the origin, and then the destination, right? Makes sense. So this is what we have. Now remember that the transitions are stored in a linked list. The transition are stored in a linked list. So we can choose whether to insert the transition at the beginning of the linked list, at the end of the linked list, or maybe somewhere in between. But now, to just simplify things, I'm going to insert this transition, at the beginning. Okay, I'm going to put it at the beginning, at the very beginning. That's where I'll put it. So let's first of all understand this transition that we are defining. What state does it belong to? This transition that we are defining, what state does it belong to? Recall that this transition that we're defining here belongs to the origin, right? It is the origin. So the transitions we're talking about here are outgoing transitions. So this transition belongs to the origin, right? Because this is where the transition is coming out from, right? We're talking about outgoing transitions. So this transition belongs to the origin, I hope that makes sense, right? So we need to insert this, at the beginning. We need the head. We need the, remember that every state, if we go back here, every state is pointing to, to the head of the transitions, to the head of the linked list of transitions. Every state is pointing to that. So we need to modify, where this particular transitions are points to. We need to modify that. So that's the first thing that we have to do if we want to insert the transition at the beginning, right? So hopefully that is clear. Hopefully that is clear. So we want to say origin, and then transitions is going to point to this new transition that we have defined. That's it. Okay. No, since we want to insert at the beginning, so we want new transition to point to, before we even like do what I wanted to do, we want new transition dot next, right? We want new transition dot next to point to whatever origin is pointing to. Now I hope this is going to like make sense, because if I do what I wanted to do now, we're going to lose information. I want it to point to origin transitions, right? This is what I want to do. I want the current transition I'm defining to point to whatever origin transitions points to. And then in the next line, I want to like modify, where origin transitions will now point to this new transition that we've defined. Origin will now point to this new transition that we've defined. Does that make any sense? So if you look at what we've done here, the very first thing that we've done here is new transition is going to point to whatever origin points to, right? And then we'll modify the transitions pointer of the origin of the origin state. We want it to now point to this new transition that we've just created, and so this will give us the effect of inserting the new transition or the current transition at the beginning of the list, right? And now finally we want to increment the number of outgoing transitions for the origin. Remember that we have out transitions, we want to say plus plus, like so. So this like increments the number of outgoing transitions. So we've allocated memory to store the new transition. We've defined the symbol. We've set the origin. We've also set the destination. And then new transition next points to whatever origin transition points to. And then origin transitions points to new transition, to this new transition here. Okay, it now becomes like the first element. It becomes the first element in the list. And then origin, we increment the number of outgoing transitions. Great stuff. So let's see if we can test this function that we have here. Now we've already prototyped this function. We've already prototyped the function in the automaton.h file. Let's first of all test this and see how this is going to be, right? Great stuff. Now let me just go into the main function. Let me just add two transitions. So I'll say this, and then we'll have to say automaton. So we have states, right? So let's add transitions. So let's say we have A. What do I want to do? It's auton, I think. It's auton add transition. Great stuff. And then let's add a transition between let's just say automaton, between automaton, and then I'll say states, and just grab the first state, like so. That is what we're going to receive. That's our origin. Then we need a destination. So like add a transit. So we'll just say states, like so. And then I'll just grab like I'll say one, like so, the second transition, like so. And let's say for now we are reading the symbol A, like so. Hopefully that makes sense. So I'm just going to like grab this, copy, and would have just like maybe said Control C, but I want you to see whatever is happening here. I don't want you to guess what I'm doing here. I want it to be clear. I want what I'm doing to be clear. So this, let's just say 0. So this is like a loop. We have a the origin is the same as the destination. So it's like we'll have like a loop on the transition. If we are to draw the graph, that is. And maybe let's say between 1 and 0, and there again. Now let's maybe try to read something different here. Let's read B, for example. So this is like an NFA. It's because for the same symbol A that we have here, we are like going to from 0. We have like on the same symbol, which is A, we are like going to different places. We're not going to a single unique place, or a unique place, right? So this is what we have here. Does this even compile? That's the very first thing that we need to do. Well, to be able to see what is happening here, I need to like modify this function that is helping me to test to print the transitions. So maybe here we'll say 4. Again, don't worry about how simple this function is looking, or maybe how hard it is. The goal is to just print something to the terminal to be able to know that okay, what we're doing is making sense. So for all the states that I have, I want to look at their transitions, right? For all the states, I want to look at the transitions. So for every state that I have, I want to look at the transitions. Now, of course, this is not a valid for loop because we need to say I++, like so. Great job. So I need to look at the transition. So for every state, I need to look at the transition. So maybe what I have to do here is to say at state. I just want to simplify things here, and maybe let's just say current state. Like so. Let's look at the current state. So the current state, and then we'll say automaton, and then we'll say states, like so, and then we'll throw in our I. So this is going to give us the current state. Now for the current state, we want to print all its outgoing transitions. So how do we do that? So for the current state, we want to be able to print all the outgoing transitions. So for this current state that I have here, I need to like print. So I'm just going to say at node, like so, like store the current transition that we are on. So I'll just say current. Transition, like so, and then this is going to be equal to current state. So whatever current, I'll point it at the to the head. Okay, I'll set the pointer to the current transition is going to point to the head or to the very first element in the list of transitions. Now as long as we have transitions, we want to be able to print these transitions on the screen. And as long as we have transitions, and maybe at the very end here, we need to modify, current transition has to now point to next for us to like go to the next transition, right? So current transition has to point to current transition next, like so. So great job. So this is what we'll do at the end. Now we want to just have like some simple print statements. Let's have some simple print statements to see what is happening here. So here we just say we just do something like this. So we'll just do something like this. So I'll say %s, like so, and then I'll also say %s, like so. I know this is like taking us a lot of time to like write everything, but don't worry about that. We'll get there. And then yeah, so we have print %s goes. Maybe let me just do something like this to sort of like format it in a better way, right? So I just want to like current transition. I just want to get the origin. I just want to get the from. We have the from, like so. And then I want to get the current transition. I just want to get the to, right? Like this. Okay, I just want to get the to. So this is what we have. So this is like going to print the transition. It's going to print the transition. And for every state, maybe let's throw in the new line here. Let's throw in the new line here so that it makes sense, right? So as long as we have transitions, we want to print the transitions on the terminal, right? Don't worry about how simple this function is, because the goal is to just print something on the terminal and see what is happening, so that we can like have we can like validate what we're doing here and say that okay, everything is good, and we maybe can make progress and like move and sort of like see how we can do something complicated. We can make this more complex. So as long as we have the transitions, we'll keep on printing the transitions for the current state. Now, if you're done for the current state, well, if you're done, we'll go to the next state and then keep on printing. And then maybe to just like check if we are correctly incrementing the number of outgoing transitions, I'm just going to like print here for the current state. After printing all the transitions, I'll probably have to like say num states like so. Maybe I'll just say percentage s like so. I'll say percentage s like so. And then what I'm going to do here is ah this is going to fail because from is a state, right? And then here I'm saying percentage s, so I have to like say representation here. Oh, I forgot. So please make these modifications. So I just want to, it's a representation we want to print. The representation, remember that current transition from is a pointer to state. But now that we've said representation here, it's going to like fish out that string representation or the name of the state that we have. That is what it is going to do. So hopefully that is a bit clear. And yeah, so we'll just say I'll just say percentage d outgoing. Going to be very descriptive here. Outgoing transitions. Going to be very descriptive. Okay, that looks good. So the very first thing that we want to do here is say current state, I believe, and then we're just going to say representation, and we just want to say we just want to say the current transition. No, it's the same current state, right? Because it's now information about the current state, the state we are on. And I just want to print out the number of outgoing transitions. Does that make sense? Does that make any sense? Does that make any sense? Great stuff. Okay, and let's just throw in the new line so that we see everything properly on, so that we have like a clear visual representation of what we are doing. Okay, that is our function. Of course, if we have any problems, let's maybe like go through. So we are storing the current transition in current state. Great stuff. And then we are pointing to the first transition in the list. Now, as long as we have the transition, we want to print it and then go to the next transition. Great stuff. And then at the very end, we are printing the number of outgoing transitions. Okay, so let's test that. Let's go back to main.c. So we've not made any changes to the CMake list or text file. So what we just have to do is compile our program with the existing make file, because we've not made any changes to the CMake list or text file. Everything is still the same, right? So we've added these transitions. So if everything is cool and everything is good, what we're supposed to do is print something to the screen. We're supposed to print something to the screen. Okay. Now let me just grab my terminal, new terminal, like so, and go to the build folder. Let's go to the build folder because that's where our make file is. And then we just want to say mingw 32, mingw 32, I think make. Oh, we have no problem. We have no errors. That's surprising because we're supposed to get errors. We've done a lot of things. Anyway, now fingers crossed. Let's try to. We have an executable. So we have an executable. So we have autonlib. No, we don't have to. Great stuff. So it prints the information to the screen. Great stuff. So let's analyze what we have here. So we have two states, Q0 and Q1, right? We have two symbols, A and B, and then between from Q0 to Q0 we have a transition. We should have maybe printed the symbol we are reading. Okay, no worries. But what matters here is that we have a transition. Remember, we are inserting at the beginning of the list. So the second transition here for 0 is what shows up, is what pops up first, because it's like the new, it's like the new, it's like the first item now, because we are inserting things, at the beginning of the list. So this second transition is what appears here for 0, because 0 has 2 transitions, which makes sense. But then Q1 has one outgoing transition. Okay, has one outgoing transition. Maybe to like correctly print things to the screen, let me just sorry about that. Let me just go back here, maybe say something like this, and let's just throw in another percentage s, I believe, because we really need to like see the symbol we are reading. So here I'll just have to say, is it the current transition? Yeah, the current transition. Then I want to grab the input symbol. Does that make any sense? Okay, great stuff. So let's now build our project, mingw32 make. Okay, nothing bad happens, and let's run our executable. And what just happened here? Does it make any sense what we are doing? So let's go back to, I think, main. Okay, so if you look at what we have here, we are supposed to, for Q1, between Q1 and Q0, we are reading a B. Okay, we are reading a B between Q1 and Q0, but why is it saying B here? Do we have a problem here in our function? Do we have a problem with our function here? So it's the current transition we're on. We just want to grab the input symbol. The current transition we're on, we want to grab the input symbol. And when defining the transition, let's go back to automaton to the main function. So remember that here we are saying we are reading A, but why does it show B? Why does it show B? So I want to save that. Let me just clear. Why does it show B? Why does it show B? Between Q0 and Q0, what we are reading is between Q0 and Q0, between Q0, which is the first state, and Q0, what we are reading is a B, is an A. What are we doing here? We are saying, okay, percentage S, destination, origin, destination, and then here it's the symbol, that we are reading, right? And then it says current transition. Then we want to read the input symbol. Here we are updating the current transition to point to next. Alright guys, this is me from the future. So I think I found the problem, like why we are printing inconsistent results. It's because in the auto add transition here, we are copying here the symbol into this. But then the way this is defined, the way we've like written our structure for the transition, it doesn't really do the copying correctly. It gives us unexpected results. So what we're supposed to do here is to replace this particular line that we have here with this. So we'll get rid of this line, and then what we need to do is we're going to say new transition dot input symbol is going to receive, we'll just say string duplication, we'll just say str duplication, and then we'll pass in the symbol here. Now that should store the current symbol that we pass in, like so. Now if we save this, everything should work and everything should be perfectly fine, right? So let's test this. So automaton.c, so this is what we have here. And if we go into the like main, let's like save everything. Now let's like run. We've made changes to our program, so we need to recompile it. Okay, does its thing. Now we have an executable, auton lib, like so. Check that out. So we have a for the first two transitions, but like I said, what shows up first here is the second transition that we have here. Now let's try b, like so, and we can really pass in anything, even a symbol that is not part of the alphabet. We'll probably have to take care of this case. So if I say C, for example, here, if everything is cool, we should be able to like, yeah, print consistent results. So if I do this up, so we have C, yeah, pops up, it gives us a C, and then Q0, Q1, Q0, Q1, we read a B, yes, Q0, Q0, read a C, and then Q1, Q1, wait, yeah, Q1, Q0, we read a B, and then Q0 has two outgoing transitions, Q1 has a single transition. Thank you guys for watching, and I'll see you in the next video. And the next video will be looking at how we can generate dot files.